Very good morning. This is inverse trigonometric functions. IITJEE point of view, very important chapter. Just board point of view, it is a simple thing. But IITJEE point of view, it is not a simple thing. There is a very good problem solving strategy. That a strategy, step by step, I am introducing and solving some important problems also in this video, even using with shortcuts. So this I will call it to be the part 1 because I am going to do it up to mains level in this one. There will be one more video of part 2, right? So let us start with from the starting introduction. That is, we know that sine of pi by 6, here the pi by 6 means 30 degrees. Sine 30 degrees is equal to 1 by 2. Sine of pi by 6, let us speak the angles in terms of radians only, not in terms of degrees, right? Once sine of pi by 6 is equal to 1 by 2, then sine inverse of 1 by 2. That is simply sine is shifted here. Sine is transformed this side. Sine inverse 1 by 2 will be pi by 6, right? So this inverse means inverse of the function. Sine is treated as a function, then it is the inverse of the function. So similarly, sine of minus pi by 4 is minus 1 by root 2. With the same logic, sine inverse minus 1 by root 2, with the same logic, it should be minus pi by 4. And sine of 3 pi by 4 is 1 by root 2. Then sine inverse of 1 by root 2, with the same logic, it should become 3 pi by 4, but it is not equal to 3 pi by 4. Why it is not equal to 3 pi by 4? Because in inverting the sine function, there are some restrictions, there are some definitions, that all that definitions we are going to discuss, right? So this is exactly the point where we are supposed to discuss the things. Similarly, you know that cos of pi by 3 is 1 by 2. Then cos inverse of 1 by 2, with the same logic, it is pi by 3. Cos of minus pi by 4 is 1 by root 2. Then cos inverse of 1 by root 2, with the same logic, it should be minus pi by 4, but it is not minus pi by 4. Again, we need to discuss the definitions here. We are supposed to go through all those definitions, right? So I'm going to do all those things now. Now, for that, definition is required. So concept 1, domain of the function f of x is equal to sin x is full real line. So that sin x function is defined from minus infinity to plus infinity, and its range is minus 1 to plus 1. But when you observe that sin x function, its graph is just like a wave, right? So in that range minus 1 to plus 1, the function sin x is not 1 to 1. But when you reduce its domain to minus pi by 2 to plus pi by 2, you can make the sin x to be 1 to 1 and onto, means fx becomes a bijection. Therefore, fx can be inverted. That is, inverted means we can find out the inverse of the function. It becomes a bijection, therefore it can be inverted. Therefore, now the domain, let us restrict ourselves from minus pi by 2 to pi by 2, and the range is minus 1 to plus 1. Then f of x is equal to sine inverse x. So domain is minus 1 to plus 1, range is minus pi by 2 to plus pi by 2. Then what is the behavior of that sine inverse x? We are supposed to know that. So this behavior, whatever I am showing here through these diagrams, this behavior, this movement is very important for the coming days, right? So this behavior, we need to understand this. So domain is -1 to +1, range is -π/2 to +π/2. How the function moves, you look here. So when x is from -1 to 0, its corresponding sine inverse x value will be from -π/2 to 0. That is the left part of the 0 to left part of the 0 here. Under the sine inverse x, it will transform. Right side, that is 0 to 1 part, is shifted to 0 to π/2 part. So under the sine inverse function, left part goes to the left, right part goes to the right, and middle one goes to middle point, right? This is the behavior of sine inverse of x. And the domain of cos x is again full real line, and its range is -1 to +1. And again, in the interval -1 to +1 of its range, when you see its graph, it is not a one-to-one function. But when you domain its interval, when you restrict its interval of the domain for 0 to π, then you can make the fx to be a bijection. Therefore, fx can be inverted, right? Once a function is made bijective, then only it can be inverted. Now in that interval, f of x is equal to cos inverse x. Its domain is from -1 to +1, and the range is 0 to π. So in this interval, let us try to understand what is the behavior of the cos function. Cos function domain is -1 to +1 like this, and the range is 0 to π like this, right? So these are the areas are given there. Now, when you take the left side part to -1 to 0, will be, this is the left side part of the domain, will be shifted to the right side part of its range, right? So when x is in between -1 to 0, cos inverse x will be from π to π/2. Here you remember that this cos inverse x function, left to right it shifts, and right to left it shifts. So 0 to 1 will be shifted to 0 to π/2. So that is π/2 greater than or equal to cos inverse x. So this behavior you are supposed to understand that. Here cos inverse x function, it will shift from left to right, and right to left, and middle point to middle point. So this is the behavior of cos inverse x we are supposed to understand, right? So there is some difference in the behaviors of sine inverse x and cos inverse x. These behaviors we need to observe it for the coming days, for the coming problems. This concept is very important, right? Similarly, when you take the tan inverse x function, its domain is the full real line, and the range is -π/2 to π/2 open set, right? So in this interval, when we take its domain like this, range like this, then here also we need to observe how it changes. So from -∞ to 0 part will be shifted to -π/2 to 0 part. That is left to left, right? And right part, 0 to infinity part will be shifted to 0 to π/2 part. So this is the, just like imitating like sine inverse function, right? So middle point to middle point. So f of x is equal to cos inverse x function. You see that its domain is again full real line, and the range is 0 to π open set, right? So in that interval only, that is 0 to π, in that domain only, cot x function becomes a bijection. Then only it can be inverted. After inverting that, so fx is equal to cot inverse x, range is becoming 0 to π. So what is its behavior? Let us try to understand. That domains and ranges are given here. Now, so this is left side part of the domain. When we transform under the cot inverse, it will go to the right side, that is π/2 to π. So x is less than 0, then cot inverse x will be from π to π/2, in between π to π/2. And when x is in the right side of 0, then cot inverse x will be from 0 to π/2. So this is the behavior of the cot inverse of x, and middle point goes to middle point. That you remember it, right? Cot inverse x behavior is like this. Just like cot inverse x, some similarity is there with cos inverse x. Tan inverse x, some similarity is there with sin inverse of x. That observation you make it here. So fifth, secant inverse x, its domain is from minus infinity to minus 1 and 1 to infinity. In that interval only, secant inverse x can be defined. Then its range will be from 0 to pi by 2, union pi by 2 to pi. Yet pi by 2 value it will not give you, right? So now again here the domain part is like this and the range part is like this. Here also let us make that observation. So the left side part, that is a minus infinity to minus 1 part, will be shifted to the right side part, that is pi by 2 to pi. And 1 to infinity part will be shifted to 0 to pi by 2 under the secant inverse of x. That observation you make it. So when x is in between 1 to infinity, secant inverse x will be from pi by 2 to 0. And that middle point is not there in the domain. Therefore, there the middle point will not come there. That is the reason this middle point is not there in the domain. Therefore, middle point is not coming there. Okay, right. So cosecant inverse of x, here the domain minus infinity to minus 1, union 1 to infinity, and its range is minus pi by 2 to 0, union 0 to pi by 2. So here again, so this is the domain part, this is the range part. How it transforms, let us see that. So here the left side part, minus infinity to minus 1, will be transformed to minus pi by 2 to 0. And right side part, 1 to infinity part will be transformed to 0 to pi by 2 part. Okay, na? Again, the middle point 0 is not there in the domain of it. Therefore, you don't worry about that. Right? These are the behaviors of the functions: sin inverse x, cos inverse x, tan inverse x, cot inverse x, secant inverse x, and cosecant inverse x. Okay, this is the complete behavior of the functions. Now, for tuning of these behaviors, this inverse function values practicing, this is for the benefit of the students. Just when they watch this video, they will get the complete ideas and what are the things they are supposed to think, right? So that inverse practicing ideas are given through some of the observations. Here, when before coming the answer, you try to guess the answer. Sin inverse 1 by 2, which is pi by 6. Okay, and here you remember that angles are given in terms of radians, because we are supposed to practice everything in terms of radians. All right, sin inverse minus 1 by 2, you observe it, it will be minus pi by 6. Okay, sin inverse of minus 1 by root 2, you try to guess its answer, right? For the practice of the student, it is minus pi by 4. It will look like sin inverse of minus x is equal to minus sin inverse x working when x is in between minus 1 to plus 1, right? Let us see the cos inverse of 1 by 2. Cos inverse of 1 by 2 will be pi by 3, right? And cos inverse of minus x will work like pi minus cos inverse of x. When we are calculating the cos inverse function on the negative values, then without negative calculate its value, and that value must be subtracted from the pi. Suppose cos inverse minus 1 by 2 I want it. To calculate that, first you write the pi, then from that without minus sign, that is cos inverse 1 by 2 is the pi by 3. This pi by 3 must be subtracted from that pi, it will become 2 pi by 3. So these things must be habituated. And tan inverse 1 is nothing but the pi by 4. And tan inverse minus 1 is, this is straight away like sin inverse function, it is minus pi by 4. It happens from the definition itself. Straight away it follows. And tan inverse minus x is working like minus tan inverse of x. Cot inverse root 3, pi by 6. But cot inverse minus x Again working like pi minus cot inverse x, just imitating cos inverse of x. So cot inverse minus root 3 will be pi minus, without minus sign, cot inverse, that is root 3 is pi by 6, that pi by 6 is subtracted, it is 5 pi by 6. Secant inverse root 2 pi by 4, secant inverse minus root 2, again with the same logic. So pi, from the pi by 4 is subtracted, it is 3 pi by 4. Cosecant inverse 2 is pi by 6, cosecant inverse minus 2 is minus pi by 6. This is for the tuning, that is a practice purpose I made it. So if the student is trying to guess the answers from it, he will get the sufficient practice. So cosecant inverse of minus x is working like minus cosecant inverse of x. So now the concept 2. The concept 2 is that from here onwards, whatever the concepts we have discussed up to now, by making use of this, some of the important results we are discussing. Number 1 is that sin inverse x plus cos inverse x is always pi by 2 for each x in between minus 1 to plus 1. So when x is in between minus 1 to plus 1, then only whole that expression is meaningful, otherwise no. But this value sin inverse x plus cos inverse x always pi by 2, right? So here you simple that how it happens, so you can convince, you can adjust your mind, you can convince yourself how it happens if you start thinking like this. Suppose you put sin inverse x is equal to theta. So automatically sin theta will be the x. When x is in between minus 1 to plus 1, we know that from the definition of that sin inverse x, theta is from minus pi by 2 to pi by 2. So that interval you write it. Once sin theta is equal to x, this sin theta can be written as cos of pi by 2 minus theta. That is also the x. But this side, once theta is from minus pi by 2 to pi by 2, then you can check that pi by 2 minus theta will be from 0 to pi interval. Now you observe these two lines, observe these 2 points. Here cos of something is equal to x, and this side is that something. Here that something is pi by 2 minus theta is in between 0 to pi. So whatever that angle pi by 2 minus theta is there, it is perfectly in the invertible interval of cos function. This the angle which is on which cos is applied, that is pi by 2 minus theta, is there from 0 to pi, which is the invertible interval of cos function. Therefore here now this cos can be inverted. Therefore pi by 2 minus theta is equal to cos inverse x. So from this, pi by 2 minus sin inverse x is equal to cos inverse x. Therefore sin inverse x plus cos inverse x is equal to pi by 2. This is exactly, this is the way student can convince, or we can convince that idea. Similarly, second point, tan inverse x plus cot inverse x is equal to pi by 2. So for each real number x can be anything from minus infinity to infinity. So here also again you put tan inverse x is equal to theta. Therefore tan theta is equal to x. Because the x is any real number, its a theta will be from minus pi by 2 to plus pi by 2 open interval. So once tan theta is equal to x, this can be written as cot of pi by 2 minus theta is equal to x. And this side, once theta is there from minus pi by 2 to pi by 2, from this it follows that automatically pi by 2 minus theta will be there from 0 to pi. Now you observe these two things. Cot of some angle is equal to x, and that angle is there from 0 to pi. Means cot is applied on some angle, and that angle is there perfectly in the invertible interval of cot. Therefore I am inverting the cot. So pi by 2 minus theta is equal to cot inverse of x. Therefore pi by 2 minus tan inverse x is equal to cot inverse x. That is same as tan inverse x plus cot inverse x is equal to pi by 2. Third one, secant inverse x plus cosecant inverse x is also pi by 2 for each x which is lesser than -1 or greater than +1, right? Lesser than -1 or greater than +1. Again, here also, you put the cosecant inverse x is equal to theta, then cosecant theta will be the x. So once x is in the interval -infinity to -1 means theta is there in the interval 0 to -pi by 2. And once x is there in the interval 1 to infinity means theta is from 0 to pi by 2. Once this, from this, pi by 2 minus theta falls in between pi to pi by 2. Here also, this falls in between pi to pi by 2. So overall, this cosecant theta is equal to x can be written as secant of pi by 2 minus theta is equal to x, right? And from this, and from these two things, we got that pi by 2 minus theta falls in pi to 0. That is perfectly invertible interval of secant function. Here the secant pi by 2 minus theta, I got it to be the x, and that angle pi by 2 minus theta falls in between 0 to pi. That is perfectly invertible interval of secant x. Therefore, I can invert that. Now I am inverting pi by 2 minus theta is secant inverse of x. That is same as pi by 2 minus cosecant inverse x is equal to secant inverse x. Therefore, secant inverse x plus cosecant inverse x is equal to pi by 2. So this is exactly the points. This way, so student or our mind can convince like that. Now let us go for some of the problems now. So whatever the concepts too, we have learned it by making use of them. Some of the problems, very important problems, mains point of view, I am solving them. So find the domain and range of the following functions. Very first function, sin inverse x plus cos inverse x plus tan inverse of x. So for this function, you see this, sin inverse x plus cos inverse x, its domain is from -1 to +1. And the range is just a singleton pi by 2. Whatever the x you take it from -1 to +1, its value will be pi by 2. And therefore, the sin inverse x plus cos inverse x value part is pi by 2. And once x is there in between -1 to +1, this tan inverse x value will be there from -pi by 2 to pi by 2. Actually, individual domain of tan inverse of x is -pi by 2 to +pi by 2 open interval. But here, x is restricted in between -1 to +1 only. Therefore, tan inverse x range will be from -pi by 4 to +pi by 4. So therefore, that part is added here. So therefore, so overall range for -pi by 4 to +pi by 4, pi by 2 is added. Then here the left hand will be pi by 4 and the right hand will be 3pi by 4. This is the overall range of this function. And its domain is that first part domain is -1 to +1. Second part, that is a tan inverse x domain, is -pi by 2 to +pi by 2 open interval. Because both must be defined, means domain must be the intersection of both of them. So that will be -1 to +1. That is exactly the answer for this question. Let us see the next function, sin inverse x plus cos inverse x plus tan inverse x plus cot inverse x function. Here again, domain is -1 to +1 for sin inverse x plus cos inverse x, and for tan inverse x plus cot inverse x, -pi by 2 to +pi by 2 open interval. So its intersection part is only -1 to +1. Therefore, its overall domain is -1 to +1. And I am thinking about the range. When you see tan inverse x plus cot inverse x, it is always pi by 2 in its domain. And therefore, this quantity is replaced by pi by 2. And from the previous argument, sin inverse x plus cos inverse x range is pi by 2. When we add up both of them, then its range will be singleton pi. Its range of the function will be singleton pi. And the third problem, sin inverse x plus cos inverse x plus secant inverse x function. Here again, sin inverse x plus cos inverse x domain is -1 to +1. But the secant inverse x is defined when x is in the interval -1 infinity to -1 union 1 to infinity. When you take the intersection of these two things, only 2 points, one is 1 will come, other is -1 will come. This is exactly the domain of the function. So overall for this function, domain has only two elements, one is 1, other is -1. Now when you calculate its values at 1 and -1, yet 1 sin inverse x plus cos inverse x, so pi by 2, and the secant inverse of x is, secant inverse of 1 is 0, therefore one value is pi by 2, and other value is yet -1, again sin inverse x plus cos inverse x value pi by 2. Secant inverse x value will be that is pi minus, that is 0. So when you add up the two things, so it will be 3 pi by 2. So its range will be 0 to 3 pi by 2. Okay. So how you got that 3 pi by 2 at -1? Sin inverse x plus cos inverse x is always pi by 2. And the secant inverse -1 is that pi minus 0. Yes. For this pi by 2, that pi is added. It is 3 pi by 2. Now you see the function sin inverse x plus cos inverse x plus secant inverse x plus cot inverse x. Here again sin inverse x plus cos inverse x domain is -1 to +1. And secant inverse x part is -infinity to -1 union 1 to infinity. Right. And this cot inverse x domain part is included there. So therefore, again here the singleton, that is only two elements, 1 and -1 will come there. Yet 1 and -1, when you evaluate its values, one value will be 3 pi by 4, other value will be 9 pi by 4. So this is the range of this function. Here the range also having only two elements. Domain is also having only two elements. These are the answers of for these four problems. Let us see the next problem. F of x is equal to sin inverse x whole square plus cos inverse x whole square. So for this function, we want to see what is its domain and range. Again here, sin inverse x, cos inverse x, domain will be -1 to +1. So overall functions domain will be from -1 to +1. Now I am trying to calculate its range. For that you put sin inverse x is equal to t. Then automatically, because x is in between -1 to +1, so t will be in between -pi by 2 to +pi by 2. So this part we are supposed to remember, because that is the range of sin inverse x. It will be from -pi by 2 to +pi by 2. So this sin inverse x plus cos inverse x can be written as like this: a square plus b square, a plus b whole square minus 2ab form. But sin inverse x plus cos inverse x value pi by 2, that is substituted, and cos inverse x is substituted by pi by 2 minus sin inverse x. So we will get that expression like this: pi square by 8 plus 2 times t minus pi by 4 whole square. This is the final expression. We will get it. It takes some little bit of small calculation. You take a paper and pen, you check that. That reaches to this step. Once from this step, you can decide everything. Here in this, that box, whatever the quantity which is there in the box, you observe that this pi square by 8 part is independent of t. That value will not change. For that pi square by 8, some non-negative number is added there. That overall that quantity becomes minimum when that non-negative quantity which we are adding is minimum. But that non-negative quantity's minimum value will be 0. That becomes 0 when t is equal to pi by 4. Yet t is equal to pi by 4. The minimum value of the function will be pi square by 8. Right? That is exactly the observation there. Therefore, the minimum value of that function is pi square by 8. And also you observe in that expression, because t is from -pi by 2 to +pi by 2. So in that box quantity, pi square by 8 is a constant. For that non-negative quantity which we are adding, When that quantity becomes maximum, then the overall sum becomes maximum. So because the t is from minus pi by 2 to plus pi by 2, yet t is equal to minus pi by 2, that overall sum will become maximum. Yet t is equal to minus pi by 2, minus pi by 2, minus pi by 4, minus 3 pi by 4, whole square will be the maximum. When you substitute that, its value will be 5 pi square by 4. This is the maximum value of the function that occurs at t is equal to minus pi by 2. That is same as x is equal to minus 1. So the maximum will occur at x is equal to minus 1, and the minimum will occur at x is equal to 1 by root 2, because t is equal to pi by 4 means is that x is equal to 1 by root 2. So the overall domain is from minus 1 to plus 1, and the range is from pi square by 8 to 5 pi square by 4. This is the answer for this problem. Let us see the next question. Sin inverse x whole cube plus cos inverse x whole cube. Here again, so this expression a cube plus b cube can be written as a plus b into a square plus b square minus ab form I am writing now. So again, here if we put sin inverse x is equal to t, like a previous problem, in terms of t, that can be adjusted like this, right? That is sin inverse x plus cos inverse x is pi by 2, and the remaining part a square plus b square can be written as a plus b whole square minus 2ab, and minus sin inverse x cos inverse x, that is minus 3 sin inverse x cos inverse x. It becomes, again here I am substituting sin inverse x is equal to t only. So by readjusting the terms of that expression, it becomes pi cube by 32 plus 3 pi by 2 times t minus pi by 4 whole square. That is the quantity which is there in the box, that you observe it. When we observe that quantity, again, so for this pi cube by 32, some non-negative number is added. So for this summation value becomes minimum when that non-negative number is minimum. That non-negative number becomes minimum when t is equal to pi by 4. Its minimum value is 0. Non-negative number minimum value is 0. So on the whole, overall minimum value will be pi cube by 32, which will occur at t is equal to pi by 4. So t is equal to pi by 4 again means that x is equal to 1 by root 2. Again, in that box, when you observe it, so that t minus pi by 4 whole square will become maximum when t is equal to minus pi by 2. So at that quantity, its maximum value when t is equal to minus pi by 2, when we substitute, its maximum value will be 7 pi cube by 8. With a small calculation, you can check that it will occur at t is equal to minus pi by 2, means sin inverse of x is equal to minus pi by 2, means that x is equal to minus 1. It gives us the maximum value. Therefore, its domain is again minus 1 to plus 1, and the range is pi cube by 32 to 7 pi cube by 8. This is exactly the answer for this problem. Similarly, you see the next problem. Once y is equal to cot inverse root cos x minus tan inverse root cos x, then what is the value of sin y? This is the question. So this can be solved very easily. You observe this. The solution is that this cot inverse of root cos x, cot inverse of root cos x, that is very first term, that is cot inverse of something, is nothing but pi by 2 minus tan inverse of same thing. That I am replacing. Cot inverse of k is pi by 2 minus tan inverse of same k. So that is cot inverse root cos x is replaced by pi by 2 minus tan inverse root cos x, and as it is minus tan inverse of root cos x is already there. This is pi by 2 minus 2 tan inverse of root cos x. Because on this y is asking us to apply the sin y is asking. Simply apply the sin in both sides. So sin y is sin of pi by 2 minus something. Sin of pi by 2 minus something will be cos of same thing. It is there in the form of cos of 2 times something, that is cos of 2 theta form. where theta is tan inverse root cos x. That is same as tan theta is root cos x, same as tan square theta is equal to cos x. Right? So once tan square theta is equal to cos x, this cos 2 theta in terms of tan square theta is 1 minus tan square theta by 1 plus tan square theta. That is replaced by cos x. It is 1 minus cos x by 1 plus cos x. So above 1 minus cos x is 2 sin square x by 2. Below 1 is 2 cos square x by 2. Overall 2 will get cancelled. Tan square x by 2 is the answer. This is the solution for this problem. Let us see the problem number 8. If cos inverse x by a plus sin inverse y by b is equal to alpha, then what is x square by a square minus 2xy by ab cos alpha plus y square by b square? You observe that in cos inverse or sin inverse, whatever the quantities are kept, you remember that all those quantities are perfectly satisfying, so that cos inverse, sin inverse are meaningful, or that quantities are definitely in the domains of that cos inverse and sin inverse x functions. Right? To solve this, very simple. For that function cos inverse x by a plus sin inverse y by b is equal to alpha, simply apply the cos in both sides. Simply apply the cos in both sides. Here you remember one trick to calculation. In the given question, if one cos inverse is there, one sin inverse is there, apply the cos in both sides, calculation becomes so simple. If both cos inverses or both sin inverses are there, apply the sin in both sides, calculation becomes so simple. Once again, I am telling you, you remember that one is cos inverse something, one is a sin inverse of something. Two different functions are there. Apply the cos in both sides, then the calculation becomes so simple. If both of them are the same functions, that is cos inverse or sin inverse, apply the sin in both sides, then the calculation becomes easy. Once we apply that cos here in both sides, then cos of a plus b form and replace that x by a y by b minus root of that that quantity, root of 1 minus 1 minus cos square this thing. So that will become 1 minus x by a whole square, 1 minus y by b whole square is equal cos alpha. From this, only this root part to one side, remaining everything other side you bring it and squaring both sides. Only root part one side, remaining everything other side you take it, squaring both sides, you will get this quantity x square by a square minus 2xy by ab cos alpha plus y square by b square is equal to. So there in that process somewhere you will get the cos square alpha also. Wherever cos square is coming there, cos square alpha, that you replace it with 1 minus sin square alpha. That 1 will get cancelled. You will get your answer like this. Then the problem number 9, solution set of cos inverse x whole square less than sin inverse x whole square. This part we want to solve it. So here you bring that sin inverse x whole square this side. Cos inverse x whole square minus sin inverse x whole square is a square minus b square form, which is a plus b into a minus b form. But you observe that cos inverse x plus sin inverse x is always pi by 2. That is a constant. And the next part is cos inverse x minus sin inverse x. We are expecting it to be lesser than 0. But pi by 2 is always constant. Therefore, we are expecting cos inverse x must be lesser than sin inverse x. But the cos inverse x can be replaced by pi by 2 minus sin inverse x, which is lesser than sin inverse x. So overall, it becomes sin inverse x must be greater than pi by 4. That is, x must be there in between 1 by root 2 to 1. Because in the domain of the function, x cannot go beyond 1. Therefore, overall the solution, that is the interval of x, will be from 1 by root 2 to 1. And you also observe that where the endpoints are included, where the endpoints are not included. That is very important part. You see the next problem. If x is in between 0 to 1, Then what is the value of tan of cos inverse sine of cos inverse x plus sine inverse of sine inverse x whole divided by 2? You observe this point in this one, that above numerator expression, when x is in between 0 to 1, with very simple observation, we can check that sine of cos inverse of x is same as the cos of sine inverse of x. In the numerator, when you remove that cos inverse, sine inverse, that remaining expressions are both are same. Then overall, in that numerator, it is there in the form of cos inverse of something plus sine inverse of same thing. Once a cos inverse something plus sine inverse of same thing is there, automatically it is pi by 2. So these two quantities are equal. These two quantities are equal. Therefore, overall, its value will be pi by 2. So in the numerator, this quantity, that quantity is replaced by pi by 2. It becomes pi by 2 by 2. It becomes pi by 4. That is a tan pi by 4 will become 1. So overall answer is 1 for this. Now the next problem, tan inverse x whole square plus cot inverse x whole square is equal to 5 pi square by 8. Then what is the value of x? This is the problem. So again here a square plus b square can be written as a plus b whole square minus 2ab form. So that is replaced by like this. So here again you put tan inverse x is equal to t. Once we substitute that, because the domain of that function is a full real line, so here in terms of t, that whole expression can be adjusted into this form. So overall, this is a quadratic equation in t. When you solve for t from here, one t is 3 pi by 4 and other t is pi by 4. Once a t is that, we know that tan inverse x is equal to t. So therefore, x will be minus 1 from both of them. So value of x which will satisfy that equation is only minus 1. So what is the solution set of cot inverse x into tan inverse of x plus 2 minus pi by 2 cot inverse x minus 3 tan inverse x minus 3 times 2 minus pi by 2 greater than 0. This is exactly is asking. So put again tan inverse x is equal to t. So cot inverse of x is pi by 2 minus t. So that expression, overall expression will become like this: t square plus 5 minus pi times t plus 6 minus 5 pi by 2 plus pi square by 4 less than 0. So from this, that expression becomes like this. So that quadratic, when you factorize it, that t values, whatever we are getting there, that will be there in between pi by 2 minus 3 and pi by 2 minus 2. So that is a quadratic. That quadratic factors, you can find it out with simple calculation. So that roots will be like this, that t must be there in between the roots, means x must be there in between them. That is cot 3 and cot 2, right? That is the answer. You can check those calculations very easily. Next problem, what is the domain and range of the function f of x is equal to a plus 2b cos inverse x, given that b is positive there. Domain and range of this function are equal. Then what is the value of b minus a is asking. When you see this, because this function is given there, cos inverse x is given there, its domain will be from -1 to +1. We know that by looking at that. Only the thing is that we have to see the range there. A is a constant, b is also a constant. Cos inverse x range will be from 0 to pi. Then overall range of this function will be a to 2b pi. A to a plus 2b pi. That will be the range. So domain is -1 to 1 and the range is a to a plus 2b pi. How you got the 2b pi? You look here. So the maximum value of a plus 2b cos inverse x. Cos inverse x maximum value will be pi. When you replace that with pi, so its value will be a plus 2b pi. And the minimum value of cos inverse x is 0. Therefore, the minimum value of overall function is a. So therefore, range of this function will be a to a plus 2b pi. Now this domain and range are equal means A is equal to -1 and A plus 2B pi is equal to +1. From this, you can find out B minus A will be 1 plus pi by pi. This is the final answer. Then you see what is the number of ordered pairs x and y satisfying this equation. 1 plus x square plus 2x sine of cos inverse y is equal to 0. So this expression, just by readjusting the terms, it can be written like this. 2 sine of cos inverse y is equal to minus x minus 1 by x. I took that x other side and divided with x. So definitely we can divide with x when x is not 0 only. When x is not 0 only, you can divide with x. That you keep it in your mind. So the minus x minus 1 by x quantity range will be minus infinity to -2 union 2 to infinity. This right side quantity range will be minus infinity to -2 union 2 to infinity. And the left side quantity range will be from 0 to 2. For that equation, left side part range is 0 to 2, right side part range is minus infinity to -2 union 2 to infinity. But he wants us to make them to be equal. So equality is possible because the common value for left and right ranges is only the 2. Means sine in 2 sine of cos inverse y is 2, means sine of cos inverse y is 1. So that is possible when x is equal to -1 only. When x is equal to -1 is only the solution. So at this instant, cos inverse y is equal to pi by 2 means y is equal to 0. Means only the ordered pair which will satisfy that equation is -1 and 0. Right? So these are the solutions. So like this, in my next videos, some more problems are going to come. Please watch these videos. Do watch, like, share, and subscribe these videos. In the next part of it, you are going to get advanced level problems. And mains level problems list also is going to come. I wish you all the best. Good luck.